Chapter 3, Lesson 2 on rational numbers. Okay, we're going to look at some categories of numbers. And the first category we're going to look at are natural numbers. And our natural numbers are what we a lot of times call our counting numbers. And we refer to our natural numbers as the set of numbers 1, 2, 3, 4, and so on. Right? Our natural numbers, if we had to give an example, we could say that an example of a natural number would be 7 or 15 or 29,142. Any of those are natural numbers. Things that are not natural numbers are 0 is not a natural number. Any negative number is not a natural number. And anything with a fraction or decimal, positive or negative, is not a natural number. Next, we're going to look at our whole numbers. And our whole numbers are very similar to our natural numbers, but now it includes 0. Natural numbers plus 0. So our set of whole numbers are 0, 1, 2, 3, 4, ... because it goes on forever that way. So our whole numbers are things like an example. We want to make sure we put 0 as an example. It might also be 12, or it might be 251. Things that are not whole numbers are negative numbers, anything that's negative, and anything with a fraction or a decimal. Our next category are integers, and integers can be positive or negative, but no fractions or decimals. We also want to say includes 0. All right, so our integers, sometimes we describe them as a set like this. We put ... because it goes on forever both ways. So we might say it's -2, -1, 0, 1, 2, 3, ... So it goes on forever in both directions. So examples of integers would be things like -2, -15, 19, 0. Things that are not integers are things that have fractions and decimals with them, whether they are positive or negative. And our last set of numbers are rational numbers. And the way we describe rational numbers are any number that can be written as a fraction. So it includes any kind of fraction, and it includes most decimals, but our decimals either have to be terminating or repeating. So it does include repeating or terminating decimals. So things that are rational numbers, examples, could be 0. It could be 1.2. It could be -3.5. It could be -4.5 repeating. Things that are not rational are things like pi, because pi never repeats. Are things like 1.21, 211, 2111, ... It has a pattern, 21, 211, 2111. We can guess what comes next, but it does not have a repeating pattern. This is not the same as this, and it's not the same as this. Most of the numbers that we look at this year are rational numbers. Right, now let's look at how we change terminating decimals into fractions. So we need to know our decimal place values in order to do this. If I have 0.8, all right, I'm going to count the place values, and I'm going to say, okay, here's my decimal. I have no holes, and I have 8. This is in my tenths place, which means that I'm going to put 8 over 10. I'll simplify it, and it gives me 4 over 5. If I have 1.0048, I'm going to say, okay, I have one whole, and I have tenths, hundredths, thousandths, 10,000ths. So I will put 48 over 10,000. And then I would simplify that, and I would say, okay, 48 can be divided by 2. 24 over 5,000. That can be divided by 2 again. 12 over 2,500. Those can both be divided by 2 again. So I have 1 and 6 over 1,250. They can be divided by 2 again. 1 and 3 over 625. And I say, well, can 625 be divided by 3? 6 plus 2 is 8. 8 plus 5 is 13. 3 doesn't go into 13. So it's simplified all the way. And the last thing we're going to look at is turning repeating decimals into fractions. And as what I do here is if I have 3.8 repeating, I say, okay, well, I've got 3 wholes. That stays there. My 8 is what's repeating, right? It's 0.8888, and so on. So 8 is going to be my numerator because that's what repeats. Since there's one number repeating, I put 19 in my denominator. If there were 2 numbers repeating, I would put a 99. For example, if I have 0.454545 repeating, I would say, okay, what's repeating? 45. That goes in my numerator, and there's 2 numbers repeating. 2 9s go in my denominator. I also need to make sure I simplify. So 9 goes into 45. It goes in 5 times, and it goes into 99 11 times. Be sure that you simplify all of your final answers for fractions.